So, hello students. So, today we are going to start a new topic for class 10th chemistry, that is chemical reactions and equations. So, we will see how chemical reactions take place, how to write the equation, how to balance the equation in the entire course of this chapter, right? So, in our world, around us, chemical reactions are taking place continuously. So, to understand that and to see the chemical change and then realize that okay, it is a chemical change or a physical change, right? So that is why it is important for us to study this chapter and apply it in our daily life. Okay, the very first thing that we are starting with is the difference between the physical and the chemical change, right? So this I think you have studied in class 7th as well. It is a revision. Okay, physical change. Physical change is a change which occurs without altering the chemical composition of a substance, right? For example, ice is getting transformed into water, water is getting transformed back to ice. So that is a physical change itself, right? The other example would be cutting paper into pieces, right? So we are not changing the chemical composition of the paper. It is again paper, right? Similarly, in ice and water, it is water and ice. Like we are not making a new product. A new product is not formed. In a physical change, no new product is formed, right? That is the way to determine whether it is a physical change or it is a chemical change. Also, physical changes, most of them are reversible. For example, dissolving sugar in water. When we are dissolving sugar in water, there is no new product that is formed. There is still water and sugar is there in the dissolved form in the water. So we can take out sugar. Like we can perform certain experiments, like you can evaporate water, we can do crystallization, and we'll get sugar back, right? So that is a physical change. Now, what is a chemical change? Coming to chemical change is a change where we are changing either the shape, size, or the state. There are alterations. A new product is formed every time, right? And that they are not at all reversible. Let us start with rusting. So I think in your daily life, you must have seen examples of rusting, right? So usually in monsoon season, so in coastal areas, we see that the windows, they get rusted, right? And even if sometimes over the period of time, your cycle gets rusted. So rust is forming from iron. So a new product is being formed and it is not reversible. We cannot reverse it, right? Okay, burning of wood. Again, burning of wood is a chemical change. So when I am burning wood or you are burning wood, you must have seen it in villages or, in bonfire, we are burning wood. So when we're burning wood, we get ash and a few gases are formed, right? But we cannot get back wood, right? You cannot produce wood back. So that is a chemical change, right? Some new product is formed over here. Right. Again, digestion of food in our stomach. So there are so many acids present in our stomach, enzymes that act on the food to digest the food and convert it into proteins, fats, right? So again, it is irreversible. You cannot reverse it, right? So once the food is digested, it is digested. We cannot get food back from that, right? So the chemical properties of the food are changed, right? Similarly, photosynthesis in plants, right? So photosynthesis takes place when we have carbon dioxide, water in the presence of sunlight. So what is happening here? A new product is formed. Can you all guess what is the new product, the product that is formed in photosynthesis? Yes, so those of you who said glucose, that is correct. So when we do photosynthesis, when plants do photosynthesis, glucose is formed, right? So from the reactants, that is carbon dioxide and water, we are getting something new, that is glucose, C6H12O6, right? So this is known as a chemical change, a chemical reaction. Here, no new substances, new substances are formed over here, and they cannot be reversed. We cannot reverse it easily into the original form. So that is physical change and chemical change. Now let us move forward to the next topic. Okay. Now, these are a few practice questions that you can ask yourself, that melting of ice, is it a physical change or is it a chemical change? So I have also mentioned the answers below, right? The most tricky one is burning of a candle. So most of the students think that burning of a candle is a physical change because, when we burn the candle, you see the wax is melting and you can remold the wax, but that is not the case. The wax undergoes combustion. So you must have seen that, there are certain gases rising up from the candle flame. So new substances, that is new gases, are formed from wax. The wax gets combusted, it undergoes combustion, it forms carbon dioxide and water vapor is formed, right? So burning of a burning of a candle is actually a chemical change. Then rusting, which we have already discussed, clearing of paper, cooking of food, formation of curd from milk. So this is for you to check your understanding, whether you have understood it or not. Let us move forward. Okay. Okay, let us come and start the heart of this chapter, that is chemical reactions. What are chemical reactions? How to write a chemical equation, right? So what is a chemical reactions? It is a processes in which, substances, they're undergoing transformation. They result in the formation of new substances with chemical properties, right? So old bonds are being broken, new bonds are formed, okay? Now let us see what is a chemical equation, which is very important for us to know, as it will help us in higher classes as well. Okay, so chemical reaction, it shows, the reactants, it shows the products, right? It also shows some symbols and formulas. Like over here, let us understand this. This is a chemical equation, which is H2 plus O2, which is forming H2O, right? So we are given certain symbols which you have studied in class 9, that hydrogen, we give it the symbol H, right? Oxygen, the symbol is O. How to write the formula that we have studied in class 9, right? So water molecule is being formed, right? So this is a symbolic representation of a chemical reaction, right? Like instead of writing hydrogen plus oxygen gives water, we can write H2 plus O2 gives us H2O, right? So this symbolic representation, it provides us with a very concise way to write the chemical equations, right? Okay, let us move forward. What are the characteristics of a chemical reaction? How do we know that, a certain chemical reaction has taken place, right? So there are certain criterias that we can follow or we can observe. So we all are budding scientists, budding chemists. So we need to, observe. Okay. So let us understand. First is change in the color, right? So if a certain reaction has taken place, we get to see a certain change in color. If you see a change in color, that means that yes, reaction has taken place, right? For example, I'll give you an example from your daily life. That is, when you cut an apple and you keep it out for some time, after some time you see there is a brown layer that develops on the slice of an apple, right? So did you ever think that why did this brown slice come over here, and what is happening? So basically that is again a chemical reaction, right? Something has happened, some chemical reaction has taken place, that is why you are getting to see that color change, right? So chemistry is all around us, all sciences are all around us, we just need to have that lenses to check, right? Next is change in temperature, right? So the reactions, they proceed with change in temperature. So either heat is released or heat is absorbed. So the reactions in which heat is released, we call them exothermic reactions, right? For example, combustion, like burning of wood, it is a exothermic reaction, right? So many of you would have seen some reactions in your laboratory, or you will be doing these reactions with the help of your teacher. If we mix acid and in water, right? So please don't do it yourself, but that reaction is also exothermic. The beaker becomes very hot. An endothermic reaction means that heat is absorbed. The heat is absorbed from the surroundings and the surroundings become colder. So there is this experiment where we take a beaker of water, and in that beaker of water we add ammonium chloride, that is a salt. So you can do this in your school laboratory with your teacher's help. So we touch the beaker and we see that the beaker has now become cold. So why is it becoming cold now? So it's quite unusual, right? We did not do anything. We did not keep it in the refrigerator. Why did it become cold? Because of the endothermic reaction taking place. If I would break it down, it is endo plus thermic. That means in. Endo means in. That means it absorbs heat. So if something absorbs heat from the surroundings, right? So all the heat has been absorbed. So you would observe coldness, right? The beaker appears to be cold. Okay. Next is there is change in the state, right? So solids may get converted into liquids, or it may get converted into gaseous product, right? Or gas to liquid, gas to solid, right? So these are all fundamental properties, right? Like for example, ice getting converted to water, right? So the change in state is there. So we need to observe it, right? Next is evolution of gas. So you must have done this very famous experiment when you take vinegar, right? And in the vinegar, when you add baking soda, right? So you must have observed bubbles are coming out. So many of you must have done that volcano experiment where we make a volcano, and inside the volcano, we put a small plastic bottle. In that bottle, we have vinegar. And in the vinegar on the top, if you add baking soda, so carbon dioxide gas is released, right? That is a acid and a base reaction happening where carbon dioxide gas is released. So evolution of gas is again a characteristic of a chemical reaction, that a chemical reaction has taken place, right? Next is formation of a precipitate, right? So precipitate is like a solid substance. So when the reaction has taken place, we see that a solid substance has settled down in the bottom of the test tube, right? So we can study this in detail, right? Again, it is a very good reaction, that is formation of precipitate. It looks like curd, particles of curd which are being settled down, which has different color for different reactions as well. So now let us move forward to represent the chemical reactions. How are we going to represent the chemical reactions? Let us understand. Okay. So firstly, in any reaction, we have reactants and we have products. Reactants are substances that are undergoing a chemical change, right? For example, we are heating magnesium in the presence of oxygen, right? So we have magnesium, right? So magnesium is represented by Mg, right? And we have oxygen. So these are our reactants. These are the substances that are undergoing the chemical change, right? So, which are forming the products, that is magnesium oxide, right? Magnesium oxide is the product that is being formed over here. Okay, so this is how we write the equation, right? So we have magnesium and oxygen that are our reactants, and MgO, magnesium oxide, that is the product, right? This is how we represent it. And this reaction, I think you must have done it in your laboratory. Magnesium ribbon, it burns with a very bright white flame. And if I would connect it to the last slide, isn't it that we studied that chemical reaction, you get to see a color change? So you get to see a color change, right? We see a dazzling white flame like, like crackers, right? And the product formed is ash-like magnesium oxide powder, which is white in color. Okay, now these are some common ions which you have to remember to write down the chemical equations, right? And there are metallic ions, non-metallic ions. So just make sure that you remember all these ions. So let us move forward. Okay, so these are some common chemical compounds that we're going to study in class 10th, that is calcium carbonate. Calcium carbonate is found in limestone, marble, chalk. It is used in manufacturing, also used in antacids in the medicines. It is used in the construction of buildings. Then we have sodium sulfate, Na2SO4. It is used in detergent, production of detergents, manufacturing of glass, and textile industry. Let us move forward. Yes. Okay. Let us come to the conclusion of our topic. Yes, that is balancing the chemical equation. Balancing the chemical equation, why do we need this balancing of chemical equation, right? This is because, for example, I have this equation, H2 plus O2 gives us H2O. Let us see what do we mean by balancing the equation, right? I have hydrogen here, I have oxygen, which is giving H2O. Balancing the equation means that the particular atoms on the left-hand side and right-hand side should be equal, right? For example, if I write hydrogen, on left-hand side, I have hydrogen. Okay. So left-hand side, I have two hydrogen atoms, and here also I have two hydrogen atoms, right? Okay. Let us check oxygen. Oxygen, I have two here, but here I have just one. That means my equation is not balanced, right? The amount of oxygen, number of oxygen atoms are not balanced, right? We need to balance this chemical equation, right? Because any chemical equation is, it correlates with the law of conservation of mass. And I know that you all must be knowing about the law of conservation of mass. That is, mass is neither created and nor destroyed in any chemical reaction, right? Okay. So we need to balance the equation, right? So in the next class, we are going to study in detail about balancing the chemical equation. In this chemical equation, you can see that it violates the conservation of mass, the law of conservation of mass, right? Because here there are two oxygen atoms, right? And on the right hand side, you would see there is just one atom. So it is violating the law of conservation of mass, right? And when we go into higher classes, we are going to do a lot of calculations with these chemical equations. So we need to always balance the chemical equation, right? Which we are going to study in next class. Thank you so much. I hope you really liked the topic. And for more information, you can contact me through my Urban Pro profile. See you in the next class.